back, now we're going to apply what we did in example 1, and we're going to write a proof using coordinate geometries. This is going to be a little bit different from the proof that you're used to doing. We've done paragraph proofs and standard 2-column proofs, and we've done some different things with proofs, and we're going to do a coordinate proof, which is it merges the algebra that we're going to have to do to help prove the coordinate geometry, okay? So let's go ahead and get started. You are definitely going to be using things like slope, coordinates of vertices, distance formula, midpoint formula. These are all going to be really important since we're using the coordinate geometry, okay? So let's get started with what we're given. We have right triangle ABC has vertices A, which is positioned at 0, 6, B, which is at 0, 0, and C, which is at 4, 0. D is the midpoint of AC. And we're supposed to prove that the area of triangle DBC, that smaller triangle right in here, we got to prove that that's 1/2 the area of triangle ABC, which is the big triangle, the big right triangle. Now, to get this started, we really want to we really need to find the area of the big triangle, and that's ABC. And the way that it's positioned, we talked about positioning, the way that it is positioned, it's really easy to see base and height. The base, since we're starting here at 0, 0, we stretch that out all the way over here, and that's going to end up being 4 units. So we're going to say B is 4. The height, starting here at 0, 0, going all the way up here to 6, the height is 6. So this is where we're going to pull some knowledge from algebraic stuff that we did last year. And remember the formula for the area of a triangle, and that is you're going to take 1/2 base times height. And so we plug all that in. We're going to take 1/2 of 4 and then multiply that to 6. And so what that in essence is, we've got a triangle with 12 square units of area. Okay, they didn't give us any units, so we'll just call it units squared. All right, now what we need to do is find basically the coordinate for point D, because we know that point D is the midpoint. Now they did draw it, and we can tell that right at this moment in time, looking at the graph, that it's positioned at 2, 3. If that's not given to you, then you're going to have to calculate it. So let me show you how to calculate that midpoint formula, okay? Let me kind of review that with you in case you can't tell. They didn't give you a graph, okay? And you had to do everything kind of from scratch. They give you, the height is 6, the length is 4, and they don't give you the actual coordinates. Then you're going to have to calculate it. So the midpoint formula, remember, you add your x's, and you're basically averaging your x's, and then you're averaging your y's. And that is how you find the name of the point that belongs to the midpoint. So we're looking for the midpoint of AC. So D, this is the midpoint right here. That's what they tell us. D is the midpoint of segment AC. That was given. So to actually name that midpoint, then what we're going to want to do is take our x's, so point C is 4, 0, and A is 0, 6, and we're going to take our x's and we're going to add them together, divide by 2, and then we're going to take our y's and add them together and divide by 2. So our midpoint lies at point 2, 3. Okay, and I think you can see that pretty easily. Let me erase just a little bit of this. Okay. All right, so let me rewrite. We've got 12 square units here. Okay, excellent. So now we know where the midpoint is, although I dare say you could probably figure that out from the graph. You may not always be able to tell from the graph, so don't make assumptions that, oh, it looks kind of close to 2, 3. Let's make sure mathematically that it is exactly at 2, 3. And that's why we crunch numbers. That's why we verify. It's definitely not something we want to get close to. We want to be precise with this. So that's why we're double checking it. Now the neat thing is the y coordinate of D is the height of this small triangle. So this ends up being your height right here of the little triangle. And you can actually count how many units it is. So D is 3 units. So triangle DBC has a height of 3, and then the base, it's going to have the same base as the big triangle, which is 4. Okay? So again, we're going to come in here and we're going to find area of a triangle. We're going to take 1/2 base times height. So that's 1/2 times 4 times 3. And so we have 6 square units. Okay? So as you look at this, you can see that we can prove numerically that triangle DBC has an area that is 1/2 the area of triangle ABC, because we know that 6 is 1/2 of 12. And so that's why you're able to prove that. So if we did a final kind of summation, triangle DBC has an area of 6, which is half the area of ABC, of triangle ABC. So that's awesome. That's how you kind of sum it all up. You let the numbers, that's what coordinate proofs do. You really let the algebraic numbers push and drive this whole process. Okay, so hold on to that. If you have any questions, let's talk about it in class tomorrow. Hopefully that was really clear for you, and we can, of course, we'll be practicing. So write down any questions you have, and thanks for listening.